gentlemen, now I wanted to create a stock to accumulate, well, how if I wanted to, so I gave the cat's out of the bag. Suppose I wanted to accumulate, to determine how many people have gotten diabetes over time. Thanks, okay. It's a good sanity check here. Okay, now this is where things get a little bit awkward, because first let's go create a stock. How do I create a stock? Do I use this? No, okay, what do I use? Okay, yeah. So I use stock, and maybe I say, you know, cumulative diabetes cases, okay? Right? Cumulative diabetes cases, whoa, okay. So I add that, and I kind of want to put it here. Now, you could try to sort of futz with it, but at least in my version of NSYMPLE, it's not gonna be a very happy sort of solution to you. So, ladies and gentlemen, there's sort of a nice way to do this and an ugly way to do it. So this gets into Kurt's question. Okay, the ugly way, I'm going to show you the ugly way first, then I'll show you the nice way to do it, okay? So the ugly way to do it is that I could edit this equation, and here, right up here, so first of all I have to say what's the initial value going to be. What's the initial value here? If we're interested in counting the number of cases from the beginning, what would the initial value be? If I want to count the cumulative number of cases from the beginning, 0. Okay, and then what I want this to be integ of? Good. So I want it to be incident cases of diabetes. Now, it's going to actually cause trouble here, so because it's NSYMPLE, it's not going to give me. So I have to connect with an arrow like that, and then have initial value, and it has incident cases of diabetes, and it'll actually work. But it's just horrible ugly. It's horrible ugly. So let's do it right, ladies and gentlemen. Let's do it right. I just wanted to show you could do that, but let's do it right. So this person is your friend again, but let's first go get the formula here. So incident case of diabetes has a formula associated with it. Let's copy that formula. I just went into equation mode. I clicked on that, and I copied this formula. Control C, or you can select it, and you can do right click and copy. Okay, because we're gonna deep six this. We're gonna do it under. We're gonna eliminate it, delete it, eradicate it. Okay, so now comes the Pac-Man time, and so I clicked on this thing to delete. And I'm gonna click on that. Now there's still this sort of symbol which has an odd resemblance to Australia without the Cape York Peninsula, and you can delete it. Okay. By in this same mode without fear. Okay, so now let's connect these two. So I could draw a flow now from this stock. So I went into this mode. Again, you click on the place it's coming from, and you go to the place it's going to, and this will be called incident cases of diabetes. And we're going to put the formula we cut out earlier back into here, but first we have to do what? Yeah, we have to connect up the dependencies. So I'm gonna sort of connect them here, but it's not particularly significant. Okay, so we connected these up using these dependencies. That indicates the logical dependencies, which is a very convenient abstraction to be able to look at. Even if you don't look at all the formulas, seeing what depends on what is often really helpful. And you'll notice, by the way, that it's the same convention we use in causal loop diagramming. You can use VenSym to create causal loop diagrams using these same tools. You just don't put in stocks and flows. You would put in these system structure diagrams, you'd put in both. Okay, so ladies and gentlemen, you click that up, and then here we'll paste in this formula that we had specified earlier. And it's just people times diabetes incidence rate. And for people, we'll go there and we'll verify, yes, that's correct. It's minus and minus. And for this guy, we'll click, and yes, it's correct. incident case of diabetes coming in, and the initial value be 0. Okay. Okay. Who has a question? Who would like me to show you something I just did? Nothing? Okay. So, ladies and gentlemen, I'd like to run this model, and now we have a model which computes the cumulative cases of diabetes over time. It also computes, of course, as before, the number of people coming in, and finally, the amounts of death and incident cases of diabetes. Okay. Suppose we wanted this population to be open, so not only to have death going on, but people coming in, due to birth or immigration. What would we do? Yeah, we could have an inflow into people. Maybe alternatively, immigrants, for example, might bring in diabetes. Already have diabetes. You could have an inflow into that. And I'll leave that for you folks to think about. Well, we've built up a little simple model here. This has what initially was just a first order delay, but then we added competing risks with the second thing, and we could see its effect on number of people, and we could see of those people has been dropping down over that period of time, and the cumulative number of cumulative cases of diabetes has risen to quite high levels. We could do counterfactual experiments where we sort of examine, suppose we were to change the diabetes incidence rate, if we could have the diabetes incidence rate. Well, ladies and gentlemen, this is an important principle. Let's run this model once with a baseline, so where we haven't changed anything. So I'm going to stop, I'm going to go into this, and we'll call it baseline. Baseline. Okay. And then let's run a scenario where we call it diabetes prevention. So this is a what-if scenario as an alternative to the baseline. So we type it in here, we press enter, and now we're going to click on this and change the diabetes incidence rate from 0.02 to 0.01. Okay, and we can see, for example, what does that do to death? Ladies and gentlemen, what did that situation do to the incident case of diabetes? When we lowered the diabetes incidence rate, what did it do to the rate at which people are getting diabetes in people per unit time? Did it raise it or did it lower it? It lowered it. You could, if you hover over this, you could actually see the graph, but you kind of got to know which is blue and which is red. Alternatively, you could click on it, and you could go over here, and you'll see the baseline is red, the diabetes prevention is blue, so it lowered it.
How did it change that incidence rate?
Okay, I clicked on this little thing here, and you can enter an alternative number exactly. And so I changed it to 0.01. Yeah.
Did you enter a new diabetes prevention that you didn't want? You want to take it out of your graph? Is there a way to do that?
Yeah, so in other words, I think what's being asked is if you graph this and you see now there's like this current thing. Yeah, so how you can do that. So this shows you the output. So this particular variable you clicked on, it shows it for all the different loaded scenarios, the different runs that you have done in the so-called data sets. To unload that, to change that, what you could do is you can go up to this control panel, okay, and you can go to data sets, and you could take the one you don't want and you can knock it out. You could even go delete that one if you're so inclined. So you can knock it out of there. And once I do that, I could close and I can go look, and that will be gone from there. Okay? Sure. I want to emphasize this tool for displaying here, this relates to the question earlier, this tool for displaying shows the current variable, current selected workbench variable, as indicated by clicking, and as indicated by up here, this shows what the workbench variable is, this incident case of diabetes. So when I click different variables, it will change the workbench. Clicking on this will show for the workbench variable the graph of that workbench variable for default scaling for the currently loaded runs. if I want to show for a particular run different variables on the same graph, I have to go to that custom graph thing we went to earlier, which is also accessed through here, and create a custom graph. So this graph here works for the current workbench variable, shows it over different scenarios. And we just saw how to eliminate a scenario. You can actually load in a scenario too, etc. Okay, so changing this diabetes incidence rate down from 2% to 1% per year. Did it lower or raise the number of people per year getting diabetes initially? Okay, what's going on over here? Why is it higher in later years? Aha. Good. I hear a lot of conjectures. What is the cumulative number of diabetes cases doing? Let's go investigate just that, and we'll come back to this puzzling issue. Well, we've lowered it. The cumulative cases of diabetes are actually lower. How about the number of people? By lowering the rate at which people get diabetes, do you think this says people, it should really be normal glycemic people. People have not yet developed diabetes. If we look at that, well, we have raised that by preventing people from getting diabetes. There's more people, you know, who live without diabetes, right? So that makes sense. How about the number of deaths? The number of deaths is now what? Higher. Okay. No, well, no. That's actually, you notice this is cumulative diabetes cases. So, yeah, this is death of normal glycemic people. So really, let's go rename those things. Let's say, okay, we say we want to rename. How do we rename? If you click on this variable thing, then we can actually go change the name. So we could say normal glycemic people. NORMOGLYCEMIC. Normal glycemic. That means people with normal blood sugar. Okay, I'll put that up in a little window here so you could see it. What happened? I thought normal glycemic people. That's what we call it. Okay. Okay. So I said normal glycemic people, and then I said death of normal glycemic people. Okay. So to make it clear, that's a good comment, Kurt. You'll notice, by the way, if I do a graph of this, it doesn't know what it is. I don't know what it is, because it doesn't have any record of it having been run. So I'd have to rerun the scenarios. But okay, but why is it? Let's examine this puzzling phenomenon. Why is it that there's this crossover there? How is it that lowering the rate at which people are getting diabetes, chance per year, actually could raise the number of people getting reported as having diabetes in later years? The bigger population. The population who would have gotten diabetes earlier, some of them are now getting it much later. They're delayed. They're delayed in getting it. Ladies and gentlemen, in the original baseline, what was the mean time until, this is almost true, what's the mean time until they got diabetes? 50 years. Now it's 100 years. So some are getting it, but they're getting it later than they would have otherwise. By the way, that statement, what's the mean time they get diabetes, it's not quite true in the context of a competing risk, because actually these people, if this was a super high rate of flow out, you can imagine the only people getting diabetes are those who do so really, really quickly. And so actually that affects how quickly people get diabetes on average. And I have things in my slides which you can go look at the derivation there. The point is here, we do have people getting diabetes later than they would have. So that population was preserved at a higher level than it was otherwise. So they're going to be getting diabetes later in time than they were otherwise. So, ladies and gentlemen, though, this is a simple example. albeit modest, of a slightly counterintuitive thing that can come from stocks and flows and from a model of this sort, that you might think that, well, lower the rate at which people get diabetes, so fewer people get diabetes, of course. Well, sort of. I mean, if you look at periods over time, yeah, at first there's a lot fewer people getting it, but later there's some people who get it later in life who otherwise would have gotten it earlier in life. So you can actually have situations where counterintuitively you can get, for certain periods of time, more people getting diabetes because you lowered the rate. It's more distally. You kept those people from getting diabetes earlier, now they're getting it later. We're getting it originally an average of about 50 years, and now an average of about 100 years. Does that make sense? Okay. And again, I'm sort of glossing over the degree to which the competing risks affects it a little bit. Anyway, that's an example of a little effect. So we've built up a little model interactively. That should put you in good stead for your problem set. Okay. So we've seen a little bit with Vensim. Any other questions about Vensim right now that I could answer since we're in this interface? Do people, if you want to see how you can put labels and things, if we wanted to put a little plus mark here, we could do that with that, or we could have it go at the so-called handle, right? And instead of going at the end, we could have it go here to the handle in the middle of this one. Similarly, we could associate things with each of these. And incidentally, if you want to put in nice loops, like if I want to mark this negative feedback, one thing I could do, I could mark this polarity. Ladies and gentlemen, is this a plus arrow or a minus arrow? It's a plus arrow. All other things being equal, increasing the number of normal glycemic people, by the way, I'm going to enlarge that. Other things being equal, increase the number of people per unit time getting cases of diabetes. So this would be a plus arrow. And I don't think there's a way to indicate that. Oh, there is. Look at that. That's a negative arrow associated with that conceptually. And if I want to put a little loop in there, I could do this comment thing, click here, and I can pick what graphics to use, and I could make it a negative, and I could have it go loop counterclockwise, right? Because it's going around, and I can have a little loop there. Okay, so that's a useful thing if you want to sort of label causal loop diagrams. You'll notice in certain modes that so-called handles are visible, and in other they're not. So that's a way to indicate sort of a negative loop associated with this. Okay, so it's going around, and then it's kind of going back into that. So I showed it as so I did comment here, and then so I did comment, and then I clicked, and then Kurt, I could pick down here under image. There's actually a set of images, some of which are less germane, and I chose the negative, and then I did loop. Yeah, I could put comments here. So oh, okay. Is that right? Okay, so I could say none. I could just say minus, something like that. And yeah, I guess this one is a big one. This one, yeah, a small one, but it works. Yeah, so that's nice. Okay, ladies and gentlemen, that's all for today.